we would like to find the image of the unit square under the mapping f of z equals 1 minus I times z plus I. So this is a linear mapping or function or transformation having the form f of z equals az plus b, where a and b are complex numbers. And in general, the effect of such a transformation is to do three things to the original object, which is the unit square. The multiplication by a complex number a will cause a rotation and a scaling. And the addition of the number b will cause a translation. So the rotation will be by an angle argument of a. The scaling will be by the modulus of a. So a will cause, multiplication by a will cause two effects, a rotation and a scaling. And the polar form of a is what tells you both the rotation angle and the scaling factor. And the translation is just by b. Okay, so the unit square has a vertex at the origin, a vertex at 1 on the real axis, a vertex at I on the imaginary axis, and then the fourth vertex at 1 plus I in the first quadrant. So the rotation amount, well, let's do this scaling. Let's do the rotation first. Okay, so we're going to do the rotation. Rotation by the argument of 1 minus I. That's A here. A is 1 minus I. And B is I. We'll do that one last. The translation is last. We have to do the rotation and the scaling first, because first we multiply by A, and then we add B. So the translation is done last. And as for the rotation and the scaling, they could be done in either order. So you could do the rotation first and then the scaling second, or vice versa, but the translation must be done last. And that's just the order of operations. The addition of b comes after the multiplication of a. So rotation by the argument of 1 minus I. So 1 minus I, there's 1 and there's negative I, so that's a nice easy one. The angle here is 45 degrees. So we have negative pi over 4. That's our angle that's in the argument of the set of all angles in arg of 1 minus I. So this is a clockwise rotation by 45 degrees. So the resulting image, now we're rotating about the origin. So this point stays fixed and we rotate the entire square about this point. So we hold this point down and rotate the rest of the square. So this side of the square is going to get rotated 45 degrees. This side of the square, well, that one, these two are harder to imagine. This one, since it's attached to the origin, it's easy to imagine that one getting rotated 45 degrees. And then the other two we can just fill in because it's a square. So this side got rotated to this, and this side got rotated here. The 0 stayed where it was. So that's the rotation. And now we would like to do a scaling. And we're going to scale by the modulus of 1 minus I, which is the square root of 1 squared plus negative 1 squared, which is the square root of 2. Since this number is a little bit bigger than 1, since it's bigger than 1, that'll make our square larger. If this number was less than 1, it would make the square smaller. So the scaling could go up or down. And so we just make it a little bit bigger. So that's not something that without labels will be evident. So let's pretend that's a square. So we've done the scaling. And now we'll do the translation. So now, finally, we will translate by I, because B was equal to I. So we just add I to each of these points, which means we move them up 1 unit vertically. Well, this one was 0, so that's going to become I, and then the others will make the rest of this what should be a square. Let's try to draw that again. Make a square here. All right, fair enough. Now, what are these other 3 points? Let's look at the mapping again. F of z is equal to 1 minus I times z plus I. So f of 0 is equal to 1 minus I times 0 plus I, which is just I. So the original unit square had 0 here. Let's just put that in another color real quick. And that one mapped to I right there. And now let's try f of I. F of I, that's this point here in red. Where did that go? That's 1 minus I times I plus I, which is I minus I times I is minus I squared, which is positive 1, and then plus I. So that's 1 plus 2I. So this point got mapped to this point. Let's try another color. Then 1 plus I, that's here in purple. F of 1 plus I is equal to 1 minus I times 1 plus I plus I. And 1 minus I times 1 plus I is 1 minus I squared, and then plus I. And 1 minus I squared is 0, because that's 1 minus, that's 2, sorry, it's 1 plus 1. Minus I squared is 1. 1 plus 1 is 2, so this is I plus 2, 2 plus I. So this number is 2 plus I. And finally, where does 1 go? 1, f of 1 is 1 minus I times 1 plus I, which is 1 minus I plus I, which is just 1. So this is 1. So these are the coordinates of the resulting square. So again, f of z was a linear transformation, a linear mapping, 1 minus I times z plus I. We are going to rotate, scale, and translate this square. So rotating a square leaves us with a square, scaling a square also leaves us with a square, and certainly so does translating a square. So the result is a square. But instead of being 1 unit on a side, we can check that the side lengths here are the square root of 2. It's been scaled by the square root of 2, and we can verify that the side length here is the square root of 2 units.